Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 4. Let's get started. Well, we've been dealing with exponents, and if you've noticed, all of our exponents have been something greater than 0. So we want to know now, what if our exponent is a 0? And so the question is, what is 3 to the 0 power? And a good guess, I think, initially is that maybe 3 to the 0 is 0. So let's check that and see if that's actually true. We do know already this. We do know that if we have two bases that are the same and we're multiplying exponents, then we can add those exponents to get an equivalent expression. So let's check that with our thought that 3 to the 0 power might equal 0 and see if that's true, and then we can go from there. So let's look. Let's say we had 3 squared times 3 to the 0 power. If that's true, then we know that our base would be a 3, and we could add the exponents, 2 plus 0. 2 plus 0, okay? And then we know that 3 to the 2 plus 0 is just 3 squared, and 3 squared is 3 times 3, that's 9. So we would have 9 on this right side. So let's take a look at 3 to the 0 being equal to 0 and see if we get the same thing on both sides. So we already know that 3 squared is 9, so we have 9 times. And remember, we said 3 to the 0 power is 0, so we're checking that. So this is a 9 times 0, and anything times 0 is 0. So on the left side, we actually get 0. And you can clearly see that 0 does not equal 9. So it wouldn't work, right? 0 would not allow us to keep this knowledge that we know about exponents that worked for all of the positive exponents. We'd like it to work for 0 as well. So 0 is not a good fit. Let's see if we can try something else. I'm going to get rid of our work so far here, and we'll try another possibility. So we know that 3 to the 0, it does not equal 0. So maybe, let's see, 3 to the 0 power, maybe it equals 3. Maybe it just equals 3. So let's try that out. Okay, so let's throw those back on there, and we'll try out this new case, and we'll see if we can get both sides to be equal. So again, if we have 3 squared times 3 to the 0, that would mean that we would be able to write 3 to the 2 plus 0. That would be correct, and then that's 3 squared, and 3 squared is 9. So again, we get 9 for the right side. On the left side, let's take a look. We'd have 3 squared, that's 9, times, and remember we said this time we said 3 to the 0 equals 3, so 3 to the 0 becomes a 3, and then 9 times 3 is 27. So 27 equals 9 obviously is not correct either, so it can't equal 3. On top of that, we also have this that we already established. 3 to the first power is equal to 3, right? That means the base 3 and one of those. So 3 to the first power is 3, and it would be a big problem if we said 3 to the 0 power is equal to 3 and 3 to the first power is equal to 3. So that's another issue. None of those worked. Okay, so that's no good. 3 to the 0 power does not equal 0, and 3 to the 0 power does not equal 3. So let's get rid of those. And let's see. Let's get rid of that. What else could it be? So let's take a look at this example again, and without guessing what that number is, let's try to solve it using some algebra here. If I say that 3 squared times 3 to the 0 is the same as 3 to the 2 plus 0, we know that that's been true for all positive exponents. So we want it to also be true if our exponent is a 0. So Let's take a look at this. So I could say that, well, I could say that 3 squared times 3 to the 0 is equal to, if I simplify this, 2 plus 0 in my exponents would be a 2. So now I have 3 squared times 3 to the 0 equals 3 squared. And let me change color so you can see what happens here. I notice that I have a 3 squared on both sides of my equal sign. So both sides here have a 3 squared. If I multiply by the reciprocal of 3 squared on both sides, then this happens. We get this 3 squared cancels with this 3 squared, and then we have 1 times 3 to the 0. Well, that's just 3 to the 0 power on the left side. And on the right side, we get the 3 squared cancels with the 3 squared, and we get 1. And so there is our actual answer. 3 to the 0 power is equal to 1. And if we test that, I think that you'll see that it works. So let me go back to this equation. 3 squared times 3 to the 0 equals 3 to the 2 plus 0. We know that that's true. Then I could say that 3 to the 2 plus 0 is 3 squared, and 3 squared is 9, just like we did before. And now I can, on the left side, 3 squared, that's a 9, times 3 to the 0 power. Well, we just discovered that 3 to the 0 power is 1. And if we say that 3 to the 0 power is 1, we get 9 times 1. And then there it is. It says what we want to see. 9 equals 9, and that's true. So in order for exponents with 0 powers to maintain what we already know about exponents, anything raised to the 0 power has to be 1. So let's go back here. Let's go to the classwork that we have here in lesson 4. We know this. We did this in our first lesson. If we have bases that are the same with exponents, we can add the exponents. That's what we used just a minute ago. We know that if we raise an exponent to another exponent, then we can multiply those exponents, and those are equivalent expressions. And we also know if we're multiplying two bases together that are raised to an exponent, then they each get that exponent. So this is these three are true, and then we add this new definition, which is any number raised to the 0 power is equal to 1. And that maintains all of our previous three expressions, equivalent expressions, and allows us to continue to work with exponents in the same manner. Okay, so let's just check all of these equations and make sure that they're going to work. There are three cases in which 0 can be involved now, and the three cases are, let's call this case A. Case A would be when m equals 0 and n is still greater than 0. Case B would be when m is still greater than 0, but n is equal to 0. And case C would be when m is equal to n and they're both equal to 0. So if both m and n are both 0, then we want to check that as well. So let's do those three and see if our thought of anything raised to the 0 power is 1 works all the time. So let's see if it works in all three cases. And if I make m equal to 0, I would have x to the 0 times x to the n, it's going to be a number greater than 0, is equal to x to the 0 plus n. Okay, and then x to the 0 we have just decided is equal to 1. And so 1 times x to the n is equal to x to the 0 plus n would just be x to the n. And then we can see on the left side, 1 times x to the n is just x to the n equals x to the n. So it turns out that both sides are equal, and it definitely would be true. So that's a good one for case A. Let's try case B, and I'll put that over here on the right side. And let's say that we have x to the m, still m is greater than 0 this time, times x to the 0, this time n is equal to 0, and that's equal to x to the m plus 0. That would have to be true. And so let's see, we've got x to the m times x to the 0, which we have said is 1, so I'm going to replace that. And then on the right side, m plus 0 is just x to the m, so x to the m. And then clearly you can see again, x to the m times 1 is just x to the m, which is equal to x to the m. So good. So far, we are making it happen. The last one we have to check is if both m and n are both 0. So let's check that one. We would say x to the 0 times x to the 0 would be equal to x to the 0 plus 0, and x to the 0 we said is 1 times x to the 0, which we said is 1, is equal to x to the 0 plus 0, which is 1. And then 1 times 1 is 1, and 1 does equal 1. So it works in all three cases. So anything raised to the 0 power would have to be equal to 1, and that works perfectly for that first equation. All right, so let's move on to the second equation, where we raised an exponent to another exponent. And remember, we're going to have three cases. I'll write them over here. I'll give myself a little room. A is when m equals 0 and n is still greater than 0. Case B will be when m is greater than 0, but n equals 0. And case C is going to be when m is equal to n and they're both equal to 0. All right, so we're going to check all three of those and see if x to the 0 equals 1 will work all the time for this equation. And hopefully it does. Let's see what we can find out. All right, so x to the m is equal to 0 in this case, so x to the 0 raised to the n power is equal to x to the 0 times n. So this would be 0 times n, 0 times n, and then let's see, we know that we're saying anything raised to the 0 power is going to be equal to 1. So this is 1 to the nth power. And over here on the right side, we have x to the 0 times n. Well, anything times 0 is 0, so that is x to the 0 power. And we said already that x to the 0 is 1, so we get 1 equals 1, because anything any 1 raised to any power is just going to be 1. You're just repeatedly multiplying 1. So that's good. A works. We've got 1 equals 1, and we're so far so good. So let's try another one. Let's do when m is greater than 0. So we're going to say x to the m, and then raise that to the 0 power. N is now 0. And again, that should be equal to x to the m times 0. Okay? And then we know that anything raised to the 0 power, we've already said anything raised to the 0 power is 1, so the left side is 1. and that's equal to x to the m times 0. Well, anything times 0 is 0, so this is x to the 0 power, and anything raised to the 0 power is 1. So again, we get 1 equals 1, and case B is true. And lastly, let's try this one more. Let's see if I can fit it over here. This is when both are 0, so we would have x to the 0 raised to the 0 power is equal to, that should be equal to x to the 0 times 0. And let's see, we have anything raised to the 0 power is a 1, and anything raised to the 0 power is a 1. So again, we get 1 equals 1, and yes. So so far, everything's checking out. Anything raised to the 0 power is a 1. So we've got one more way to check this, and actually, I'm gonna come back here. I'm gonna come back, and I want to see if I can copy these things here, copy those there, and go back here, and then I want to paste, and I don't know if I'm gonna be able to do that. Yes, I am. Okay, awesome. Okay, so there we have that, and we haven't checked them all yet. I know the checks are still there, but we'll cross-check them. Okay, so those are our 3 cases again, so I didn't have to write those over. So let's try it out. We have x times y, and n is going to be greater than 0, so we're going to leave that an n. And then that is going to be equal to, well, this would be n here as well. Let's say that n equals 0, so we're checking this one. So this is a 0, and that should be equal to x to the 0 times y to the 0, and let's see if we get the same thing. Well, anything raised to the 0 power is a 1, equals x to the 0, that's a 1, times y to the 0, that's a 1, and 1 times 1 is 1. So 1 equals 1, and I think you get the idea that we figured it out, right? We know that anything raised to the 0 power is a 1. So that's going to be really important for us moving forward. Let's take a look at exercise 5 and 6. Okay, so writing in exponential notation and expanding this goes like this. Exponential notation is going to be like putting our decimal point right there, right at the 8. So we're going to say this is equal to 8 times 10 to the 1, 2, 3. 3 decimal places we had to move that. So that's 8 times 10 to the 3rd power. And then we're going to add, and instead of our decimal point being between the 8 and the 3, now we're going to think about it being between the 3 and the 7. So that is a 3 times 10, and this time we would have to move it 2 places, so that's 10 to the 2nd power. And then plus, this one would be a 7 times 10 to the, well now, look, our decimal point is going to be between the 7 and the 4, so we only have to move that 1 place. So, and then lastly is a 4, so that's 4 times 10 to the 0 power. Okay, and then I just want to take a look at these and make sure that we get the same answer. So let's look at 8 times 10 to the 3rd power. Well, 10 to the 3rd power means 10 times 10 times 10. That is 1,000, and 8 times 1,000 would be 8,000. So that's 8,000. And then we have 3 to the times 10 to the 2nd power. Well, 3 times 10 to the 2nd power. 10 to the 2nd power is 100. 3 times 100 is 300. And then we have 7 times 10 to the 1st power. Well, 10 to the 1st power just means 110. So that's 7 times 10, which is 70. And then the last one is where we come into our our work today. We know that 10 to the 0 power is 1, and 4 times 1 is 4. So then when we add all these up, we have 8,374, and that is exponential notation. Okay, so let's try that again. Maybe I can write a little smaller to fit all these on here. So let me see if I can get my pen a little bit smaller. We're going to have, the first one we're going to have is going to be a 6 times 10. And remember, I'm imagining my decimal is here, and that means 1, 2, 3, 4, 5, 6 decimal places I've moved. So that's 6 times 10 to the 6th. And that's my first one. And then hopefully you've noticed that there's a pattern now. And since I started with, look up here, we had, well, that's not what I wanted to do. We had 10 to the 3rd, then 10 to the 2nd, then 10 to the 1st, then 10 to the 0. And we're going to follow that same pattern. So I'm going to add, my next digit is a 9. So that's 9 times 10 to the 5th. Plus my next digit is an 8 times 10 to the 4th. Plus my next digit is a 5. So that's 5 times 10 to the 3rd. Next digit is a 0, so that's 0 times 10 to the 2nd, plus my next digit is a 6, so that's 6 times 10 to the 1st, and I didn't quite fit it on there, but the last digit is a 2, so that's 2 times 10 to the 0 power, and we should be able to recognize our number from that, and let's just check it to be sure. 10 to the 6th power, so that's 10 times 10 times 10 times 10 times 10 times 10 is going to be 1,000,000, and 1,000,000 times 6 is 6,000,000. So there's 6,000,000. Plus 10 to the 5th power, that's going to be 100,000, so that's 9 times 100,000, that's 900,000. 900,000 plus 8 times 10 to the 4th, well, that's 10,000. So 8 times 10 is 80,000. So that's another 80,000 that we're adding. And then we're getting down here, 10 times 10, that's 1,000 times 5, that's 5,000. And then we have 10 squared is 100. 100 times 0 is 0, so that's just 0. And then 10 to the 1st is 10 times 6, that's 60. And then let's see, 5 times. And then 10 to the 0 power is 1. 1 times 2 is 2. Okay, so when we add all these up, it's 6,985,062. And there it is. We can see it in exponential form. Okay, so that is lesson 4. I hope that helps. See you again next time.